Hello everyone, today we are going to discuss ratio and proportions. So this is an important topic when it comes to CAT. Why? Because the concept of ratio and proportion is an important one for the aptitude examinations. Questions based on this chapter have been regularly asked in the CAT examination. So in the CAT examination they have been asked direct or application based. Okay? And in fact, questions based on this concept regularly appear in all type of aptitude exams like XLRI, CMAT, NMIMS, SNAP, NIFT, IRMA and even the bank PO exams. Moreover, understanding and having a better understanding of ratio and proportion is also going to be helpful in the area of data interpretation. Great. Now, let's look at some of the important properties of ratio. The first we have with us is, if we multiply the numerator and the denominator of a ratio by the same number, the ratio remains unchanged. So what is this property trying to tell us? So let's assume that there is a ratio which goes by A by B. Okay, and if I multiply the numerator, which is A, and the denominator, which is B, by M. So if I multiply both by M, I get MA upon MB. Now even MA upon MB will have the same ratio as A by B. Let me give you an example. Suppose the ratio is 3 by 5. Okay, so 3 is our numerator and 5 is our denominator. Okay, so if I multiply 3 by 5, it gives me 15, right? So 3 into 5 and 5 into 5. So I multiplied both numerator and denominator by the same number. Now this gives me 15 by 25. Now if I want to cut it and get to the simplest form to find the ratio, it would be 5 3 is 15 and 5 5 is 25. So as you can see, both of them are similar. Great. So this is the first property of ratios, that if we multiply the numerator and the denominator of a ratio by the same number, the ratio remains unchanged. Great. Now let's look at the second property. So here it states that if we divide the numerator and the denominator of a ratio by the same number, once again the ratio remains unchanged. Okay. So this time, instead of multiplying the numerator and denominator, we are going to divide the numerator and denominator by the same number. Once again, what does this mean? If we once again have a ratio A by B, okay, and we divide both numerator and denominator by a certain number, let's assume D. So if I divide A by D and also B by D, then the ratio which I'm going to get after this will once again be A by B. This and this will both be same. Once again, let's understand this property by using an example. So if I have an example, the previous one, 3 by 5. Okay, so 3 by 5. Now if I divide 3 by 5 both by, let's assume, by 10. So 3 by 10 and 5 by 10. Now what happens is that this becomes 3 by 10 multiply 10 by 5. Because it becomes a reciprocal, because we are moving from division to multiplication here. Now 10 cuts 10 and we are once again left with 3 by 5. Therefore, this and this ratio is once again exactly similar. The ratio remains unchanged when we are dividing a numerator and a denominator of a ratio by the same number. Great. Now let's look at the third property. The third property is the denominator equation method. So it's called the denominator equation method. And it states that the magnitude of two ratios, can be compared by equating the denominators of the two ratios and then checking for the value of the numerator. So if you are ever asked to find that that which ratio is bigger, okay, or the what is smaller, so what we are going to do is we are going to equate the denominators of these ratios and then check for the numerator. Okay, let me give you an example. Suppose we have to check for 8 by 3 and 11 by 4. Okay, so now we have to first of all ensure that the denominator in both of these is exactly similar. Okay, so we know that for both 3 and 4 there the LCM would come out to be 12. The common multiple that they have is 12, right? So I will move both of these towards 12 as a common denominator. Okay. So for 8 by 3, I will multiply both numerator and denominator by 4. So it becomes 32 by 12. For 11 by 4, I am going to multiply both numerator and denominator by 3. This comes out to be 33 by 12. Now, you see, it's very easy to understand that which one is actually a bigger ratio, the magnitude of which is bigger is 11 by 4, because when we have the same denominator, 12, and then we check for the numerator, here it's 33 while here it's 32. Therefore, 11 by 4 is bigger. So if I put the greater than or the less than sign, it would look something like this, that 8 by 3 is less than 11 by 4. Great. Now let's look for the fourth property. The fourth property states that the ratio of two fractions can be expressed as a ratio of two integers. Okay, the ratio of two fractions can be expressed as a ratio of two integers. So let's assume that we have a ratio which goes like A by B is to C by D. Now I can rewrite it as A by B divided by C by D, right? And if once again I go for the multiplication, it becomes A by B into D by C, which comes out to be AD by BC. And that is what it is trying to tell us, that the ratio of two fractions, which we have here, can be expressed as a ratio of two integers, because you see A and D and B and C, both of them are integers here. So now we are expressing this ratio in the form of two integers ratio. Got it? Great. Let's move on to the fifth property. So the fifth property states that if either or both the terms of a ratio, are a surd quantity. Surd means that they are in some form of under root. Okay. So if they are a surd quantity, then the ratio will never evolve into integral numbers unless the surd quantities are equal. Okay, I know this sounds very complicated to understand, that we have surds, integral values and stuff like that, but it is a very easy concept to grasp. Okay, so now see, what we are trying to tell here is that if there is a number root 3 by root 2, okay, root 3 by root 2, now this can never be represented as integers. Why? Because both of these are irrational numbers, so can never be represented by integers. But what is the significance of this property for us? Okay, so suppose while solving a question, you come across a situation where, for example, root 3, okay, root 3 appears as a part of the process. Okay, so in such a case, it would be safe to assume that root 3 will also be part of the answer. So if you get root 3 while solving during the process, then there is a very good chance that root 3 will also be part of the answer. And since the only way the root 3 can be removed from the answer is by multiplying or dividing by the expression root 3, right? So if I want to remove root 3, the only way is that if I multiply root 3 by root 3, which gives me 3, or I divide root 3 by root 3, which gives me 1, right? So until any of these situations are happening, root 3 will be in the answer. For example, the formula for the area of an equilateral triangle is root 3 by 4 a square. So here, at most of the times, root 3 will always be in one of the answers. Great. Now let's move on to the sixth property. The sixth property is talking about the multiplication of the ratios. Okay, so it is very simple. Okay, and I'm sure that all of you already know about it, but it is important to just have a brush up on all of this before we go and solving into more questions of ratio and proportion. So what it is saying, that the multiplication of the ratios A by B and C by D comes out to be AC by BD. And I know we have done this and subconsciously used this property a lot of times in the earlier properties, but this is all that this property is trying to tell us, that if we multiply two ratios like A by B into C by D, it gives us AC by BD. I don't think we even need an example to comprehend this kind of a property. Great. Let's move on with the next one. The next one says that ratio of A by B when compounded results in the same ratio as before. Okay. Now this again, this does sound complicated, but is actually very, very simple, and we can easily understand what it is trying to say. Okay. Now what it is trying to say is that A by B is there, right? But what if there is also A by B into A by B? This becomes A square by B square. Now again, the ratio of this is once again comes out to be A by B. Therefore this and this are same. But once again, if I divide A by B into A by B into A by B, this becomes A cube by B cube, and once again the ratio comes out to be A by B. This means that the ratio of A by B when compounded means multiplied or divided by itself in the same ratio, it gives us the same ratio as before. Got it? So that's all that is trying to tell us. Great. Now let's move on to the eighth property. The eighth important property of ratio is that if A by B equals C by D equals E by F equals G by H equals K, then the value of K is. So all it is trying to tell you that if this is the situation, then the value of K comes out to be A plus C plus E plus G divided by B plus D plus F plus H. Okay. This means that if there is a ratio which is A by B will be equal to C by D will be equals to E by F equals to G by H, and then it equals to a particular number or an integer K, then the value of K could be found in a way that if we add all the numerators and divide them by all the denominators. There are very less chances where this kind of equations will be used for you, but once again it is very important to understand so that during examination you don't have to think a lot while solving these equations. Great. Now let's move on to the ninth important property of ratios. So here it states that if A1 by B1, A2 by B2, A3 by B3 till AN by BN are unequal fractions. So they are unequal fractions. Then what would be the ratio? Okay, so if A1 by B1 and A2 by B2 until AN by BN are unequal fractions, then the ratio would be once again A1 plus A2 plus A3 till AN divided by B1 plus B2 plus B3 till BN. Got it? And the important part, and actually a very interesting part, is that this particular value will lie between the lowest and the highest of these fractions. Okay, so this means that this property lies between the lowest and highest of these fractions. Great. Now let's move on to the last property that we have for today. The last property that we have with us is property number 10. And here it is trying to tell us that the maintenance of equality when numbers are added in both the numerator and then denominators. Okay, so the maintenance of equality when numbers are added, see what we are trying to understand, that the maintenance of equality when numbers are added in both the numerator and the denominators, then what happens basically. Okay, let's understand this by an easy example. Suppose there is a ratio which comes out to be 20 by 30. Okay, and we want to add numbers to both numerator and denominator, but we do not want to change the fraction and the ratio as it is. Then we need to find a value in which we can add the numbers but the ratio won't be changed. For example, here we know that the ratio comes out to be 2/3. So if we have 20/30 and we have to maintain this particular ratio, what we are going to do is we are going to add 2 to 20 and 3 to 30, as this comes out to be 22/33, and this once again comes out to be 11 2 is 22, 11 3 is 33, which is 2/3. So all it is trying to tell you that maintenance of the equality when numbers are added in both the numerator and then denominator, and how to go about it. So basically, in other words, the ratio of the additions should be equal to the original ratio to maintain equality of ratios when two different numbers are added in the numerator and the denominator. Great. Now this sums up our entire video on the important properties of ratio, and this was an introductory lecture, and I'm sure that all of you are very well equipped with the ratios by now. Now I would request all of you to go and look at the documents available on the EduRev platform and try solving a test on the ratios to see where you stand and how much you have learned. And then come to the next videos in order to solve some practice questions with us. Thank you, and I hope you have a happy learning with EduRev.